A duck walks up to an ice cream truck and he says to the man, "Run in the truck. Hey, bop, 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 got any sherbet?" The man said, "No, we just sell ice cream. It's cold and it's fresh and it's all homemade. Can I sell you a cone?" The duck said, "No, I'll just go home." Then he waddled away, waddle, waddle, till the very next day. Duck walked up to an ice cream truck and he says to the man, "Run in the truck. Hey, bop, 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 got any sherbet?" The man says, "No, like I told you before, we only sell ice cream, but you're hard to ignore. I'll make you the sherbet. I'll mix it up quick, just as long as you promise to stop playing this trick." The man made the sherbet quite fast, so finally the duck had his sherbet at last. Then he waddled away, waddle, waddle. Then he waddled away, waddle, waddle, waddle. Then he waddled away, waddle, waddle. It was the very best day.
Okay. We can use chemistry to explain how the ice cream man was able to make his instant sorbet. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. However, a juice such as fruit punch does not freeze at this temperature because of a colligative property known as freezing point depression. Freezing point depression is used to explain why the freezing temperature of a pure solvent is higher than the freezing temperature of a solution of that same solvent. This equation is used to calculate this change in freezing temperature. The delta TF represents the change in freezing point temperature, the KF is the freezing point constant, and the M stands for molality, which is moles of solute over kilogram solution. Fruit punch has a higher molality than pure water because solutes, such as sugar and flavoring, are dissolved in the water, and this causes there to be a change in freezing point temperature. Because of this, a cooler solution is needed in order to freeze the fruit punch. This is where enthalpy change comes into play. Enthalpy change is the change in temperature of a solution that occurs when a solute is dissolved in a solvent. This equation is used to determine this change in enthalpy. The delta H represents the change in enthalpy, and this is calculated by subtracting the heat of reactants from the heat of the products. If this delta H value is positive, then it is an endothermic reaction, which means that heat is drawn from the surroundings into the system in order to dissolve the solute into the solvent. If the delta H value is negative, then it is an exothermic reaction. An exothermic reaction releases heat from the system into the environment. These concepts can be used to explain how the ice cream man is able to make his instant sorbet.
Okay. Instant sorbet is made using 2 parts of ice, 1 part of water, 1 part of salt, and 1 part of fruit juice. For this experiment's purposes, we'll be doubling this recipe, but in order to show you how much you'll need in order to make this, we've shown it for you right here. So the first step is to add the ice, water, and salt into a large plastic Ziploc bag. This is the Ziploc bag where the enthalpy reaction takes place. So as the salt dissociates in the water, the reaction that takes place is endothermic, which means that it's absorbing heat from its surroundings. The next step is to add the fruit juice into a smaller plastic Ziploc bag. This fruit juice is what will be frozen in to make the sorbet. In order to freeze the fruit juice, you need a lower temperature because of the solutes added to the juice. This lower temperature is only achieved by the reaction between the water and the salt. So, in order to get this lower temperature to freeze the fruit juice, we add the small plastic bag into the larger Ziploc bag in order for the fruit juice to be around that colder temperature. For this experiment, we will show you that the salt is very important in this reaction by also comparing it to a setup without the salt in it. So now that we've made the 2 bags and mixed all of them together, we're going to shake them up. Shake, 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 shake,
Shake it like a Polaroid. Country girl, shake it for me, girl. Shake it for me, girl. Shake it for me. Country girl, shake it for me, girl. Shake it for me, girl. Shake it for me. Shake, shake, shake. Shake, shake, shake. Shake your booty. Shake your booty.
So, after we finish shaking it, this is what we end up with. So, let's see if the experiment actually worked. So in this bag, this is the one we put the salt in. And as you can see, the fruit juice froze into a lovely sorbet. This is the bag that didn't have any salt in it. And as you can see, it didn't freeze at all. So this just goes to show you how important the salt is in this reaction. The salt, when it dissociates in the water, is an endothermic reaction like we said before. So it absorbs heat from its surroundings, and this heat comes from the surroundings, which includes the fruit juice. So as heat is absorbed from this fruit juice, it gets colder, which is what allows it to freeze into this lovely sorbet. So we hope you enjoyed our video, and we hope that you like this recipe so much that you want to try it at home by yourselves. It's really fun and really easy to make. We hope you enjoyed it.